All right. Good afternoon, everyone. My name is Karthik. I work as a staff engineer within VMware Global Support Services, and been like close to 9 years debugging, troubleshooting, anything around vSphere, and especially around anything to do with storage. And that includes vSAN, which is the core area where I work as well. So coming back to today's session, it's about the vSAN performances, best practices, where as part of our day-to-day job, where we work with quite a lot of customers around performance and its areas. And that's where we thought, okay, there is something where we need to have a lot of all these details which are missing when we work with the customer. That would really help all other customers as well. So this presentation was a trigger with all the work that we did with our customers. So in the next 30 minutes of time, right, we're going to be discussing about quite a lot of details around how the components or the nodes are designed, especially around the compute area, around the disk groups, and to an extent we will be covering something on the network part as well. So before I move on to all the performance and other details, the first and foremost thing, the documentation. I know pretty much everyone overlooks the documentation, but they got ton of details, and all we speak in any of the sessions, in any of the tech talks, everything kind of boils down to our documentation. But unfortunately, there could be certain issues in here, but do take it a point to review those documentation, especially around performances and around the design guidelines as well, because those are two areas ultimately everything boils down to on how a setup is going to be. So what does it matter? So before we get on to our session, so there are certain things that I want to kind of set very clear so that you know what to expect out of the session. So we're going to be going in detail, okay, and that's going to be touching upon many of the design considerations as well. And when it comes to design, there is nothing good or there is nothing bad. It all boils down to what kind of environment that you have and what is the expectation or what is it kind of meant, or it is configured for. Those all boils down to whether this particular option that is something will be useful for you or something that you can even ignore them. So which means not everything that you need or not everything that we're going to be discussing, maybe it would be applicable for you, but some may not as well. So with that ground rules, let's get going. All right. So why does performance matters? There's nothing to kind of explain, it's self-explanatory. But the first thing is the old age says, right? A slow and steady wins the race, but these days it's like marathon plus sprint, so you can't go ahead with like kind of a slow performance any down that can bring down your entire business as well. And being a storage, the impact could be magnified into multiple things that your entire business comes down to a grinding halt. So why does it matter? So that's where all these best practices will help you to ensure you take a right choice and the decision going to help you in terms of your performance for vSAN specifically. First thing, CPU. When it comes to CPU, right, people usually don't bother much about it because it's taken for granted. Anytime when you order a node or order a server, you take it for granted. Okay, it comes with the, flashy, the new CPU that are, kind of coming with your any individual node that you kind of buy with them. But there are certain factors that can have an impact on your vSAN performance as well. So many people first they kind of think, okay, how many like 1P, 2P servers. The reason why we highlight all these 1P or 2P is that these days people always go for a dense server, means like kind of 2-socket servers with like say 1 or 2 TB of RAM, which is kind of super dense, right? These kind of decisions can have an impact on vSAN as well in an indirect way. I'll tell you why and how. So first thing, when you have all these things, right, so there are a lot of factors like NUMA and other considerations that comes into play. So usually we see with the explosion of number of cores in a single socket these days, those days of like kind of beefing up with 4 sockets or like kind of 8 sockets, those are all gone days. With single socket you can do much more things than you were doing with like kind of quite a number of hosts actually. So with that in mind, 1P in certain conditions, especially with AMD and other the latest EPIC processors, they run much better. So you have to decide on which or the configuration of your node. Is it going to be 1P, 2P? Second thing, about the frequency of it. It looks very simple at a higher level, but it's like how fast your CPU can kind of charge up itself so that it can get the job done in a shorter span of time. So the higher clocking is something that we recommend. And finally, when it comes to performance, so make sure your BIOS is set to high performance. That's the power policy that we expect with our customers. But most of the servers or OEM vendors provide with the balanced performance. which is something not we recommend, because a lot of other things like C1E and other states, or even for that matter Turbo Boost, which helps you to kind of scale up your performance for vSAN, that in turn drives in increasing the throughput as well as decreasing the latency that you see with them. So that's very important. And when we come to the memory part, nobody have a look, or like they don't consider that much at all into this particular section. So they kind of take it for almost like granted. Like all they care is like how dense it is. Is it, am I getting a 1 TB or like 512 GB or like it's a 2 TB? That's all they look at. But there are two important things that I want you to take note of. Once you know what it is, then it makes really sense on how it would have an impact on vSAN. But most likely your OEM vendors would take care of it, but it's always good for you to know so that you could take an informed decision. The first thing is about the kind of DIMM that you're going to be kind of placing in the platform. There are like kind of two DIMMs broadly classified. Like there are other type of DIMMs, but I've taken two which are most commonly used on 99% of the systems. That is LR DIMM and R DIMM. So what kind of DIMM? Because LR DIMM is something which starts from 64 gig and is a little bit costly as well. And but when it comes to performance, they give you superior performance, and the density also goes high. But when it comes to RDIMM, they perform much better, but their range is very less. Like the max RDIMM that you can afford in the market is maximum 32 GB, which means if you're populating those memory DIMMs, your memory on the individual node comes down drastically. So that's where you kind of take or you decide which is suitable for you. If you want a more denser server and a faster server, it's LRDIMM that you go for, right? And the second thing that is very important is how you populate these memory in your in the platform. That is very important. We have there is another slide which speaks more in detail, which we will be covering later. And the final thing, Intel Optane memory is something which we don't support, so that's going to be coming out down the lane in another few releases later, just for an FYI kind of thing. So this was I was speaking about how you populate your DIMMs. This is really important. For that matter here, in this case we have a single socket. On both the sides you have channels like A, B, C, those are the channels, and then you see the slots where you put in your DIMMs. So if you see them, in total you have 8 channels, and every individual channel has got 2 slots in them. So if you kind of fill up one slot on both the sides, that is 8 DIMMs, right? So what would happen is that the CPU or the DDR RAMs or the DIMMs that you have got there would kind of clock in at 2666 MHz in that particular range. So which means somewhere if you are placing all the 8, not instead of 6, you will be working at a range or a bandwidth at about close to 21 GB per second, gigabytes per second. And now let's say this is at 2666 MHz. At that frequency this operates when you populate this model. Now when you step back, okay, I want a much denser server, meaning I want 1 TB or 2 TB of configuration. So you go ahead and populate the other slots. So what would that mean is, it would increase the operating frequency from 2666 to 21333. That is 2133 megahertz, meaning your theoretical throughput or the bandwidth that you're going to be affording is kind of much lesser. Back then in 2666, remember, it was 21 gigabytes per second. It comes down to 18 to 19 gigabytes per second. And there are certain other configurations as well. Let's say in case of 2P and other things, like say 2 sockets, when you keep populating every slot that is available for you, you would be reducing the operating power. It can come up to almost 15 to 16 gigabytes per second as well. So that's the one which affects on how fast you access or how memory is being accessed, and that can have an impact on memory. So in some of the testings we did, the LR DIMMs, especially with AMD EPYC processor, which are high on number of cores, the LR DIMMs actually perform much better way. So have these things in mind when you kind of do it, but most likely your hardware vendor would usually take care of it, but you just have a check with them. That really helps you. It's a hidden benefit that you can easily get, but there are some cost factors will be at play. I'm not saying no to it, but at the end of the day, as long as you get a faster operating or kind of a working vSAN cluster, that's something that you expect, and that's what you want for, right? So this is very important. Have a look. Similarly, in case of Intel, also Intel Cascade Lake, that's the latest one, the flashy one, which also has certain bits into it, the same way the channels and how they are distributed, how you populate the memory, everything also comes in here. So have a conversation, what kind of DIMMs and what is the performance that you want. So when you have those conversations, the OEMs or the vendors would be able to explain you much more in detail. Yeah, so that's something good to know. And coming on, like compute, okay, moving away from compute when it comes to disk groups, right? That's where the entire like the actual heavyweight or heavy lifting happens. So the disks, right? People ask, okay, how many disk groups is something that is optimal? Because any customer with whom I have kind of worked with, or they kind of work on like, okay, hey Karthik, I have a cluster here, this is working, it's fine, but I have other projects where I need to create, or I need to kind of set up a bigger clusters. What do you suggest? This is a common question what we get from our customers. So based on the internal experiments, what we have done, what we see is that if you have like say one disk group, that's a bare minimum. Max of 5 disk groups you can have for every individual node. What we see is the most customers prefer 2 to 3 range, 2 disk groups or 3 disk groups range. And when we tested it in our labs, when you have like 2 disk groups, right, your performance doubles. And similarly, when it comes to 3, it doubles. Like basically the IOPS gets increased with the same set of latency when I mean. Now, when you increase it more than 4 and 5, right, the linear or the improvement in the performance is not so linear, which means the sweet spot is at 3 disk groups. This is some performance angle as well. And the other angle is, let's say there is something that's going to go wrong, right? There is something called a fault domain, so which also comes into play. So if you have more than one disk group, that is 2 or 3 disk groups, it's always better. So go for a configuration which has like more than one disk group, but unless and until you really need anything more than, I mean, like kind of 3, go for it. Otherwise, stay between 2 and 3. That's the recommendation. And if you are using not so flashy kind of a beefy config for all flash, make sure you have your storage policy, which includes a stripe width. Basically, you are trying to split objects into multiple components, spreading across your entire cluster, so that all your IOs are not going to go into one single caching layer or one single node. It's spread across the cluster, making use of the clustered resources. That's something we strongly recommend our customers to do as well, right? And have in mind, when you're going for the latest version we have from, recent versions do support RAID 5 and RAID 6 concepts as well. And when you're going for RAID 5 and RAID 6, you have IO amplification, which means every single reads and writes will be amplified by 2x or 3x in this particular configuration, or if you set this particular policy to your virtual machine. So when you do that, what would be the impact? Do not change that dynamically as and when you need. Yes, you can afford to do it, but if you know what you're doing, then it makes sense. But if you are not sure of what you're doing and you just, okay, hey, I want to just change this particular policy from RAID 1 or RAID 0 to RAID 5 and RAID 6 dynamically, and you have a lot of VMs and they're like kind of heavy VMs, obviously you're going to be pumping a lot of IOs, and that's going to impact your performance for your virtual machines as well. So make sure you time it appropriately, like during the like kind of a low watermark period, or like kind of a weekend or anything like where you don't really get impacted, or the number of IOs that are generated by the VMs are pretty much less. And finally, big data applications, that's something we have seen with many customers as well, because of a lot of things coming into on the VSAN platform, right? We see people usually go with the default policy of FTT equal to 1. You don't really need to, for 2 reasons. One, space savings and other things. And coming back to our context here in terms of performance perspective, you really don't, because the redundancy is all kind of taken care at the app stack or application level itself. So you don't have to really do that. And most importantly, you are not letting your IO hop out into the network. So the network hop is cut down on here. So which means you save, or the application runs even much better when you have in this particular configuration, especially for big data applications or any application that has redundancy built in at the application level. And Intel Optane NVMe disks are like something which are fast performing. Intel claims it's more than like 20-30, at least 30% faster than the fastest SSD. But it is definitely, I'm not disputing that number, but if you are looking for a faster performance, or at least the cache layer, go for NVMe kind of devices. I don't want to be a vendor specific, but in general NVMe is much better. And congestion is something very important. If you start seeing congestion, means basically you are trying to kind of pedal back and say, okay, hey IOPS, go ahead and stop. You are pushing back to the guest OS and back to the application, slow down. That's the message of what congestion is in a nutshell. And it can come for multiple reasons, but you can broadly classify in 2 buckets. One, it could be a hardware problem. All right, the hardware problem could be a bad or a failed disk, or something which is about to fail, or the controller has some issues, or anything of that sort. Or under the hardware bracket itself, your hardware is not properly configured for the amount of data that it's going to give you. right? That's the hardware. Software side is something like maybe some of the components has a known issues or like kind of a bug or something of that sort. So those are two things when you see. And when you see congestion, that's at high time that you kind of trigger the alarm, and then either you kind of start looking into it to figure out what is causing it. If not, raising a support request with VMware support to help to identify what it causes. And the reason I'm highlighting again this congestion, it doesn't like, it's not like it improves your performance, but basically it increases or decreases your kind of a performance, and it can be at times severe that it can entirely bring down your cluster as well. So it can be very dangerous. It's always, I suggest, nip it at the bud. All right, network. All these things what we saw, right? So if you look at the VMware HCL, like bring your own device kind of concept, where you can build your own vSAN nodes and stuff. You will see SSD, hard disk in terms of a hybrid configuration or a HBA controller, but you will never see a network card. But network being a networked storage is kind of a backbone to how your vSAN cluster is going to perform. And if you are using all flash, make sure it's 10 gig, nothing less than that. And if you're using NVMe of those sort of devices, always go for a 25 gig or above. The reason I'm saying is, these faster caching devices like NVMe can easily kind of overwhelm the underlying storage, the networking stack or the bandwidth it gets. So they are super fast that you can easily kind of fill up or throttle or kind of get the NIC card to stop dropping packets. And when you drop packets, right, that is equally dangerous, and in terms of when it comes to performance as well. The more the packets drops, the more the degradation that you would see. So it can be even the latency what you experience because the packet drops can go up to almost like 500 or even a second for every single IO. So which means that's very dangerous. So getting a sturdy network and enough bandwidth for your workloads is very, very important. Trust me when I say this. And we see a lot of customers, the moment they start seeing, so that's the area where we look at, okay, what is the configuration, is all the components in the HCL of what we define. If everything looks good, the next thing that we logically look at is, what is happening with the network? Is it the network stable enough? Because that's where we see many a times customer runs into a problem. And when it comes to network, so it could be not a properly sized NIC card that's in place, or the IO that is being pumped is too much, and quite a lot of other things. And finally, a couple of things we noted, like one is traffic shaping. Traffic shaping in itself doesn't help you or decrease the performance, but what happens is it doesn't allow you to scale when you really need to. Let's say there is a situation where the bandwidth is already congested, so it stops, which means if it's going to restrict your vSAN, so the performance, everything is going to come down, the IOPS and everything. This was some time back, but these days you don't really have it, but there is something called Cloud Health that we use it. So those health checks actually verifies all these things and tells you, yes, if you have configured, this is something you have to, that is causing a problem, or this is something that you have to kind of go ahead and disable or kind of alter it. If at all we are kind of reaching to a point where the congestion starts kicking in and reduces your performance. So this is no more something you have to do it manually these days, it's automated, but I wanted to highlight that there are quite a lot of configurations. So it's not because there are configurations and you can configure, you can do that, but unfortunately you shouldn't be shooting your own food. That's very important. Jumbo frames, so it doesn't have a direct impact on the vSAN performance, but it has an indirect way. So when you have your setup, everything configured in jumbo frames, then go for jumbo frame configuration for your like VM kernels and the uplinks as well. If you have jumbo frames, it helps you to reduce the CPU cycle. When the CPU cycle reduces, that's used by other threads and things to fasten up. So it's a kind of an indirect one, it's not a direct performance. So if you have it, go for it. If your setup doesn't or isn't configured for jumbo frames, then it's okay. It's fine, you can ignore them. And the last thing, right, driver and firmware, it's very, very important, okay? Trust me when I say it's very important. There are a few areas, something which are really critical for vSAN. When it comes to drivers and firmware, whatever we spoke all this while, like CPU, memory, all those things are static. So you configure it one time, you get it right at the beginning, that's it. You're not going to change that pretty often. But this is something that keeps changing. It's very dynamic. Like when you update or when you patch a server, there are good chances this can be changed or modified. So when you change different versions or like kind of drivers and firmwares, make sure three things you have in mind. It's up to date, it's compatible, and when I say compatible, it's compatible with the version that you're running as well as compatible with your firmware as well. Because some of them may work with any kind of firmware, but some of the driver versions specifically work with the minimum set of driver or a firmware version. Only with that it is compatible. And we have seen a lot of issues with the customers, like it could be performance, it could be packet drops when it comes to NIC cards, or when it comes to HBAs, there could be devices where it kind of bails out when the I/O is too much, wherein the disk gets kind of disconnected or kind of goes offline for whatever reason. So it's very important you get that right and always verify them. And so the last option, right, when it comes to NIC card, it's something people tend to overlook. At least for HBAs, I mean, I see usually customers are concerned on what version they are going into. But when it comes to the NIC card version, right, they just update. They don't really look through a lot of things. There are quite a lot of features when it comes to a driver that are like kind of helps you with the performance of VSAN as well. How? Let's say there is something called NetQ, or you have like RSS, they help you. So sometimes some of the driver versions what you had may had the RSS enabled by default, but in the later versions it could be disabled as well. So verify what is available and what is not available for that particular driver. And how do you get that? The shortest way and easiest way is look to the release notes that gets downloaded automatically when you download a driver. This is something not many of the customers look at all. They just take it for granted. When you download the driver has in a zip format or something which also has a text file. Just open up once. If you're using like say Intel i40 or Broadcom NICs or like kind of Emulex or anything of that matter, look through it. It will have a known and resolved issues. Apart from it, it will have what features does it support. That's very important when it comes to the performance of your NIC, and especially the buffer. Many times we see the packets are getting dropped because they didn't have enough buffers or the rings were getting full. So that's an area where I would request you to focus before you start even the activity of patching or modifying the drivers. Very important. Alright, so these are all things we have seen. So if you look at, we've been focusing more towards the hardware side, but we haven't come anything on these, vSAN software side of things, right? Let you know that vSAN is built in such a way that it can dynamically adjust to the kind of underlying configuration that you have. So which means if you have like an all flash, it knows that this is all flash configuration, it adjusts accordingly so that you get the optimum performance. So that's already built into it. So that's where you wouldn't see much of focus on what do you do or fine tune things, but it will be all in terms of suggestions. Okay, how do you set up or how do you configure every individual node in a vSAN cluster? And the most important thing when we say keep your vSAN versions up to date, I usually I get a giggle from a customer when I'm speaking on a phone. Okay, hey, it's okay. I mean, every vendors or every support asks me to keep an update version, but there are two reasons to it. One, there are known issues which we want to do it, and second thing is there are a lot of improvements on vSAN that could help you as well. Like some of the components, let's say resync is something important that's been modified. Let's say if you are on an older version, it's time for you to upgrade. And there are improvements that resync and snapshots and other things that adds to your performance as well. So stay up to date with the latest version. And last point, do not make configurations on the fly, or make sure you're kind of streamlining them. That's very important. The moonshots would be like stale objects. This is something where we don't usually see with customers, but if you are in POC and you're moving your POC environment into your production, so that is when you get to see this particular problem coming up. So stale objects helps you to occupy space as well. So when you delete them, that helps you. When it comes to performance, they don't impact them directly. This is also an indirect benefit. What happens is that your component distribution gets skewed because of the stale object. So which means all your IOs somewhere which was supposed to be distributed is being pumped into one single node or one single capacity disk, which is like something is not so great or not so good to be in, right? That's one. And yeah, log snippets, just to tell you like when a congestion happens, right? These are the log snippets that you need to be aware of. If you're anytime seeing this thing, that's a time for you to kind of hit the alarm button, right? And these log snippet is very important, and especially the 2 KB articles that you find here is something I would suggest you to bookmark. It's not for vSAN as such specifically, but it includes for anything on the vSphere storage stack as well. If you see any of these devices like highlighted ones, X028, that is a read command in SCSI terms. And if you're seeing like getting a check condition, right, HDP, do you see there X0X0 D02? That's important for you to note. If you're having it, something is not right. Device drivers, firmwares, that's the area you're going to be focusing next. Yeah. All right, that brings us to the end of this particular session. So make sure you always stay up to date with the versions. Configure your nodes in the right way so that you don't have to relook at it down the road or down the lane, one. And finally, when you are dealing with performances, be methodical. There's nothing that helps you. If you are like trying to change a lot of things, you don't know where you start, what happened, what ended up. So make sure you make one change at a time and go in a proper fashion. Okay, this is the numbers that I got before the change and this is the number that I got. that really helps you. And pretty much when it comes to support, I'm sure if you have already worked, they would be following through a methodological process, and that's what we go by. So, and definitely that's something I would suggest, don't mess up there at that particular one, because a lot of things get skewed easily if we miss that one important thing, right? Right, so finally, those are the additional resources I would suggest you. Those are some of the VMworld videos as well, and you have some documentation landing pages. They have a ton of information, whatever we discussed, and a lot of other things that helps you to build a successful vSAN cluster. Yeah, right. All right, that's pretty much I had for the day, and thanks very much for taking time and joining this particular